Okay, so perform the indicated operation. So again, this is a review of what we've done. So number one, let's suppose you had this rational expression. So we have 3x squared plus 3x divided by 4x squared minus 24x plus 36. And that rational expression is being multiplied by this rational expression. Okay. So when you multiplying, now the operation here is multiplication. So when you're multiplying rational expressions, what's the first thing you need to do? Factor. Okay, notice that only a couple of people were able to tell me that. So you're going to factor. So how do you factor that first numerator? Factor out of 3x, so the GCF is 3x. I get 3x times what? X plus 1? What about the denominator? So I'm going to go up to the side. I'm going to rewrite that denominator. I'm going to just go off here. 4x squared minus 24x plus 36. I'm just going to kind of do a little bit of work there. What should I do first? Over here. Factor out of 4. GCF is 4. So I get 4 times x squared minus 6x plus 9. Okay. Now, am I done with this? So if this was on test 2, would this be your answer? No, because I can factor x squared minus 6x plus 9 further. So I get 4 times x minus 3 times x minus 3. So that goes here. Okay? Now, before we move on, let me just mention this. I'm going to go ahead and rewrite 4x squared minus 24x plus 36 over. Remember, the first step in factoring everything we do is to look for a GCF other than 1. And so when I do this, the GCF is 4, but let's suppose you forgot about that, and you just went ahead and you factored. All right, so when I factor this without even factoring out the GCF, let's see, 2x and 2x, and for 36, let's just try 6 and 6. The last sign is positive, right? So that means these signs in here are going to be the same, and they're both going to be negative. Now let's check to make sure I get that middle term. What's the outer?
12.
Negative 12x. What's the inner? Negative 12x. When I add them up, do I get a negative 24x? Yeah. And then a negative 6 times a negative 6 is a positive 36. But that doesn't go here, because what else can I do to these two binomials? I can factor out a 2. So when I factor out a 2, I get 2 times x minus 3. And here, when I factor out a 2, I get 2 times x minus 3. And this 2 times this 2 is 4, which is what this was. Okay? So if you forget to do the GCF first, just don't forget to make sure you factor completely in the end. All right, times. Now let's go to the numerator here. How do you factor that? That's the easy kind because the coefficient of x squared is 1. So, I'm sorry, that is not 63. That was 3, excuse me. 3. It's 3, not 63. Okay, so it'll be x plus, x minus, right? X minus 3, x minus 1. What about the denominator? How can you factor the denominator? Say it again? I'm sorry? No, it's not.
You can factor an x.
You can factor out an x. Yeah, it's not the difference of 2 squares. But you can factor out an x. You get x times x minus 1. Okay, so I factor. The first step was to factor. Now what's the next step? Reduce. Okay, what's the first factor that you see in the numerator?
3x.
Well, I mean, Okay, 3 is what I want you to say. The first factor is 3. Remember, factors are separated by multiplication symbols. 3 times x plus 1 times x minus 3 times x minus 1. So there are actually 1, 2, 3, 4, 5 factors in the numerator. What's the first factor in the numerator that you see? 3. Will 3 reduce with any factor that's in the denominator? No. All right, so I'm going to leave 3 alone. What's the next factor that you see? X. Will x reduce with a factor that's in the denominator? Yes, which one? The x right here. Now remember though, when you cross them out, you just don't cross them out like that. You got to remember the fact that 5 divided by 5 is what? 1. And remember, when we cross them out, we put 1 to their place. 5 and 5 is 1, 5 and 5 is 1, and 1 divided by 1 is 1. So when I cross these out, x divided by x is what? 1. So we put 1 to their place. So you're left with a factor of 1 in each case. What's the next factor you see? Is there a factor of x plus 1 in the denominator? Where? Where?
In the denominator beneath it or on the other side?
It doesn't matter. Is there a factor of x plus 1 in the denominator?
Yeah.
Where?
No.
I don't see an x plus 1 anywhere.
Oh, I'm sorry. I'm mistaken.
Okay. There isn't any, right? Okay. What's the next factor that you see? X minus 3. Is there a factor of x minus 3 in the denominator? In fact, there are 2 of them. Doesn't matter which one I use. But when I cross them out, I put factors of 1s in their place. What's the next factor that you see? X minus 1. Is there a factor of x minus 1 in the denominator? No?
Yes.
Yeah, it's right below it. Why'd you say no? What'd you say? Okay, all right. But yeah, it's right below it, right? Okay,
Mr. D, quick, why would only the x minus 3, why would can't cancel both of those out?
because you don't have 2 up here. You only have 1. It's kind of like saying if I had 3 divided by 3 times 3. You're not going to you're not going to divide all these out because that's really 3 over 9, right? Which is 1/3. So all you can do is reduce one of these. So you get 1/3. Same reason. The only way you could have reduced all of those if there was an extra 3 up here. All right, now just leave your answer in factored form. So when you look at what you have 3 times 1 times x plus 1 times 1 times 1. How are you going to write that? 3 times x plus 1. What about the denominator? You have 4 times 1 times x minus 3 times 1 times 1.
4 times x minus 3.
4 times x minus 3. Leave it like that. There's your answer. Now, sometimes you may see the answer written as without the factors. In other words, you may see it where they distributed 3. But I would just leave it in factored form. So you could say that, or if you distribute, you would say 3x plus 3 divided by 4x minus 12. But leave it in factored form. All right, number 2. You have 7x squared minus 7x divided by x squared plus 2x minus 3. Now this rational expression is being divided by this rational expression, x plus 1 divided by x squared minus 7x minus 8. All right, so remember, this time we're dividing. So what do you remember? This is the first thing you have to do when you divide rational expressions. Change it to multiplication. So that's where you're going to multiply by the reciprocal, right? The reciprocal. And so you leave the first fraction alone. The first fraction stays as it is, the first rational expression. So you get 7x squared minus 7x divided by x squared plus 2x minus 3. And then you multiply that by the reciprocal of this rational expression. What's the reciprocal? Okay, x squared minus 7x minus 8 divided by x plus 1. So now you went from a division problem to a multiplication problem. And now the rest is what you've been doing. So what's the first step? Or what's the next step? Factor. So how can I factor that numerator? The first numerator. GCF of 7x. So 7x times x minus 1. What about the denominator? I think it's 3 and 1, so it'll be x plus 3, x minus 1. Is that correct? So the outers are negative x, the inners are 3x, and you do get a 2x. And then 3 times the negative 1 is a negative 3. All right, the numerator, that's that second rational expression, that's going to be x minus 8 times x plus 1. That's the one that works. And you can check. The outers is x, the inners are negative 8x. When you add them up, you do get a negative 7x. And then can I do anything with x plus 1? Can I factor x plus 1? No. So you just rewrite it. All right, so that was step 1. All I did, well, or step 2 in this case. So all I did was factor. Now I'm going to reduce common factors. What's the first factor that you see?
7.
7. I see a 7 as a factor. Will that 7 reduce with, and how many factors do I have in the denominator? How many factors do I have in the denominator altogether? 3. Will 7 reduce with any of these 3 factors? No. What's the next factor you see? X. Will x reduce with any factor in the denominator? No. There's no factor of x in the denominator. That factor is x plus 3. She's confusing this with this, and we talked about this. If I have 3 divided by 3 plus 2, can you reduce these 3's like this?
No.
No, you cannot, because that 3 is not a factor. If that was 3 divided by 3 times 2, then could you reduce the 3's? Yes, now you could, because that's a factor. So she was thinking that this x right here and this x plus 3, let's say, I can reduce that. What was that? Was that what you said you could reduce?
I was thinking about the ones out the parentheses.
The same reason you can't do that, because that's not a factor. Remember, I asked you how many factors are there? There are how many factors? 3. What are they? They are what? X plus 3. Did I say x or did I say x plus 3? X plus 3. What's your next factor? X minus 1. What's your next factor? X. There's no factor that's just x. Okay? So can I reduce that? So make sure you understand that you cannot do this. Okay? You cannot do this. That's incorrect. What's the next factor you see? X minus 1. Is there a factor of x minus 1 in the denominator? Yes. When I cross them out, make sure you remember that this is division. X minus 1 divided by itself is what number? 1. So I'm left with factors of 1s. What's the next factor that you see? Is there a factor of x minus 8 in the denominator? What's the next factor that you see? So I can reduce those, right? And so that's all I can do. So what's going to be the answer to the numerator? Leave them in factored form. 7x times x minus 8. And then the only thing left down here, x plus 3 times 1 is just x plus 3. All right, so that's number 2. Okay, number 3. Suppose you had this. Two w squared divided by w squared minus 7w plus 12 times, and in parentheses, 4 minus w. So 2w squared divided by w squared minus 7w plus 12. Now, what some students do, they make a mistake and they divide out these w squareds. Why can't we do that? Why can't I take this factor w squared and divide it with this w squared?
Because it's not the first step.
Because of what?
Because it's not the first step. We're supposed to.
No, that's not the reason. When people do that, they think that remember you can only reduce factors, right? Is w squared down here a factor?
Oh.
No, because of the subtraction symbol. So don't make that mistake. All right, so this down here, w squared is not a factor, 7w is not a factor, 12 is not a factor. The whole thing together can be considered a factor, the whole thing. But you can go further with that. What else can you do to this trinomial? You can factor it even beyond that, right? So I'm going to get 2w squared divided by, now let's go ahead and factor that. Let's see, 4 and 3 I think work. So w minus 4 times w minus 3. Okay? All right, now, let's talk about this 4 minus w that's in parentheses. In all the problems we've done before that, and even if you go back to the last class period, when you wrote these rational expressions, you physically saw a numerator and you physically saw a denominator in every case. Here, you don't see what part of a rational expression? The denominator. But what is it understood to be? 1. Now, when I rewrite it here, I'm going to rewrite it as 4 minus w divided by 1 without the parentheses. The reason there was a parentheses to begin with was because you didn't see a fraction to separate certain things. So if you did not put the parentheses, I just want you to understand this, that if the parentheses wasn't there, then according to the order of operations, the only thing you're multiplying this by is the 4. According to order of operations. Remember, order of operations, you multiply and then you do what? Subtract. So if there's no parentheses here, then that means that the only thing you're multiplying this rational expression by is 4. Whatever that is, then you subtract what? W. But that's not what I meant this to be. So this right here is supposed to be this. So you have to put that in parentheses because this rational expression has to be multiplied by what? 4 minus w. Not 4, but what? 4 minus w. So when you write it as a rational expression with the denominator 1, this is what you see. So if you go back to all the others, you don't see parentheses at the beginning. See, none of these had parentheses. If you go back and look at your original problems, none of those had parentheses. Okay, so just be aware that if there's no denominator that you physically see, then there's going to be an expression here with parentheses in it. All right, now, so I factored. Now, that's all the factoring I can do. Now let's reduce. What can you do? Opposite. Okay, good. So we started talking about opposites last class period. Which two factors are opposites of each other? 4 minus w and w minus 4. So remember, the opposite of 4 minus w is, remember, all you're basically doing is just changing the signs of the terms. So 4 becomes what? Negative 4. A negative w becomes a positive w. But negative 4 plus w I can rewrite as what? W minus 4. Okay? And I see a W minus 4, don't I? Now remember, when we divide opposites, so if I look at 8 and negative 8, what is that equal to? Those are opposites, so when I divide them, what do I get? Negative 1. Because this is really, if you look at this, 8 into 8 is 1, 8 and negative 8 is negative 1. So 1 divided by negative 1 is negative 1. Okay? I could have also did negative 8 divided by 8 instead. It's still going to be equal to what? Negative 1. So meaning this, that when I reduce it, this time I get negative 1 divided by 1. Here I got 1 divided by negative 1. But I still end up with what quotient? Negative 1. So when I do this, we talked about that. It doesn't matter when you reduce your factors. It does not matter whether you make the denominator a negative 1, the numerator positive 1. Does not matter. But we prefer, in most cases, we prefer when we cross these out like that to make this factor which one? Positive 1, and this a negative 1. All right? So they can't both be negative 1s, because what's a negative 1 divided by negative 1? Positive 1, and you know that when you divide opposites, it's not supposed to be a positive 1, it's supposed to be what? Negative 1. So one has to be positive, one has to be negative 1. And so therefore, what's the answer? 2 what? No, I'm sorry, negative 2w squared over w minus 3. That's your answer. All right. Number 4. Okay, 4, we have 25 s to the 12th divided by 18. Now this rational expression is being divided by this rational expression, 5 s to the 6th divided by 2. All right. What's the first step? Change it to a multiplication problem. So you can multiply by the reciprocal. So change division to multiplications. But remember, when you do that, the first rational expression stays as it is. So 25s to the 12th divided by 18. And then you multiply by the reciprocal. So the reciprocal of this rational expression is 2 divided by 5s to the 6th. All right, now let's kind of remember some of the things we did with these. Now, notice that all of my factors are monomial factors. You don't see x plus 5, you don't see 2x minus 3, you don't see anything like that. They're all monomial factors. So the way I'm going to do this is I'm going to deal with the coefficients first. Coefficient and constants. So in other words, see this 25? Well, that 25 reduced with any factor in the denominator. The 5. So I'm going to say 5 into 5 is 1, 5 and 25 is 5, right? Okay? Now, don't worry about the variables just yet. Let's just deal with this individually at the end. The next factor that you see is a 2. Will that 2 reduce with any factor in the denominator? This one right here, right? So that'll be a 9. Now let's go ahead and multiply this out. So I'm going to get, that's going to be 5 times s squared times 1, which is what? 5s squared, right? In the denominator, that's going to be 9 times 1 times s to the 6, which is 9s to the 6. You all agree? All right, now, remember, you have factors of s in the numerator, you have factors of s in the denominator. Can I reduce that? Yeah. You know, remember, you can reduce it the long way. So in other words, how many factors of s are there in the numerator? 12. And so that means s times s times s times s. How many times? 12 times, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there are how many factors of s in the denominator? 6. 1, 2, 3, 4, 5, 6. And then we're just going to reduce common factors. So these divide out, 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 and so on. So I'm done with reducing my common factors. So how many factors of s are left over? 6. That's a long way. But last semester you learned the quickest way to do this, because this could have been 120 factors of s. You wouldn't want to write all that out. So you had 12 in the numerator, you had 6 in the denominator, so those divide out. How many do you have left? 6. So basically you use the quotient rule, though, as a shortcut. So when you divide like bases, what did you do with those exponents? You subtracted. So in other words, if I had s to the 12 divided by s to the 6, then that's going to be s to the 12 subtract what? 6, which is this s to the 6. So that's a quotient rule. So when you divide like bases, you subtracted your exponents. So it was always the exponent of the numerator subtract the exponent of the denominator. So this right here that I'm circling, that's just s to what power? 6. Now go ahead and write your answer better. So what's the answer? What's going to be the numerator? 5s to the 6, and what's the denominator? 9. All right, let's do one more. So this will be number 5. All right, number 5, you have 2x squared minus 8 divided by 6, and that rational expression is being divided by this one, x cubed minus 8 divided by 18. All right. So notice the directions to say perform the indicated operations. What operation am I performing right now? Division. So you know how to deal with that. What's the next step? Change multiplication. So I'm going to get 2x squared minus 8 divided by 6 times the reciprocal. What's the reciprocal? 18 divided by x cubed minus 8. So that's where I'm at. Okay, what's the next step? Factor. So let's look at that first numerator. I'm going to go ahead and write it out just like I did before. So 2 times x squared minus 8. How do I factor that? GCF of, what's the GCF? 2. So that's 2 times what? X squared minus 4. Now in test 2, would you have left the answer like that? No, because you want to factor completely. So this binomial, that's the difference of 2 squares. So I get 2 times, and when I factor this, that's going to be x minus 2 times x plus 2. So that's the numerator. So in my numerator, I'm going to get 2 times x minus 2 times x plus 2. The denominator is just this monomial. So I'm going to rewrite it. Times, now let's go to the numerator. The numerator, 18, is just a monomial. I'm just going to rewrite it. Now let's look at the denominator. The denominator is a binomial. But what kind of binomial is this? Difference of 2 cubes. So let's go off to the side and figure out how to factor x cubed minus 8. So we have x cubed minus 8. Now remember on the you had difference of 2 cubes on your last test. So in doing the difference of two cubes, remember the approach that you took. When factoring the difference of two cubes, first of all, remember that the answer is going to be a binomial times a what? Trinomial. Don't make the mistake and think that this binomial is x minus 8, because it's not x minus 8. So the approach you took was you asked yourself, all right, if this is the difference of two cubes, then I'm going to rewrite, from my work, I'm going to rewrite these two terms as something raised to a third power. And so hopefully I can fill in these parentheses. What times itself 3 times is x cubed? X. What times itself 3 times is 8? 2. So I found, remember we call this F and L? So I found F and I found L. And remember when you factored the difference of two cubes, it was F minus L times, and do you remember what the rest was? F squared, and then what else? Plus, good. F, L, and then plus L squared. So when I factor x cubed minus 8, knowing that F is x and then L is 2, what's that binomial now? X minus 2. All right, now let's do the first term here. So the first term here is I take F and I multiply by itself. F is what is x, and x times x is x squared, plus F times L, which is what? 2x, plus L squared, so 2 times 2 is 4. So that goes here. Now remember, once you factor the difference of two squares or the sum of two, the difference of two cubes or the sum of two cubes, this trinomial cannot be factored further. So don't even try. You'll never be able to factor this. So that's x minus 2 times x squared plus 2x plus 4. So that's this denominator. All right. So now we reduce. What's the first factor you see in the numerator? 2. Will that reduce with a factor in the denominator? Yeah, the 6. So 2 and a 2 is 1. 2 and a 6 is 3. What's the next factor that you see? X minus 2. Is there an x minus 2 as a factor in the denominator? Yeah. So x minus 2 divided by x minus 2 is what number? 1. So you put 1s in their place. The next factor you see is x plus 2. Is there an x plus 2 as a factor in the denominator? No. The next factor you see is 18. Can 18 be reduced with a factor in the denominator? Yes. To 3. 3 and 3 is 1. 3 and 18 is 6. And that's all I can do with regards to reducing. So what's the answer? And leave it in factored form. 6 what? Oh, you're forgetting you are the factor in the numerator. 6 times x plus 2, right? Over or divided by this trinomial, x squared plus 2x plus 4. So that's your answer. All right? Okay. So that was a quick review of what we've done in the previous two sections, or the previous 2 days, I guess.